Thanks for joining today, LVH. We're going to talk about startup security, and I want to intro you saying that LVH is a principal at Latacora.com. Here's the website, by the way. It's a company focusing on security teams for startups and security for startups. That's why I think this conversation is going to be interesting today. LVH is also known as a fellow of Python Software Foundation, where he wears multiple hats. I know that you LVH like Clojure. I'm not sure what changed since then. Maybe you started, I see that there's some mentions of Rust in your blog post, so we'll talk probably about that as well. Many people know LVH is actually as the author of Crypto 101. It's an introductory course and book on crypto. LVH started it in 2013 on a PyCon presentation, and then it evolved into online and freely available course on crypto, focusing on breaking, as far as I remember. Anyways, I want to kick this. Thanks for joining us. I want to kick this off with actually a question that I'm really curious about. How did you get into security practice, and what were your motivations to get into security? What was your path getting there?
Yeah, so I am extremely fortunate, and well, I'm extremely fortunate in a lot of ways, but one of the specific ways that I'm extremely fortunate is that so my dad remarried, and so by the time I was born, he was already 50, and he basically retired when I was born. And he was an engineer his entire life. So I grew up in a house with like a bunch of electrical components laying around, and like always access to an oscilloscope, and you know, tons of components for like computer components laying around, and someone to explain how all of them worked. So that, you know, that's certainly where I just got into like computers and technology in general. And then in addition to that, so my dad was worked in magnetic heads, and I think there were sort of like two things where it started to become obvious that maybe security was a thing for me. When in grade school, we had, in most classrooms, we had computers. And this was like before that was super normal. Like it was unusual for people to have computers in their classrooms back then. And one of the main reasons is one of the teachers there was also an amateur programmer. And so he like put together, like he had this like massive library of like Turbo Pascal, like educational software. Like he would just like put together, you know, like all sorts of educational software for the stuff that he was teaching. And there was no particular reason behind that other than, you know, he just had a hunch that this whole computer thing was going to be important one day. And the earlier that he could expose all of his kids to computers and get them comfortable with it, the better. As what I think is a neat example of, to put it into Dungeons and Dragons terms, having a high enough int score, having a high enough intelligence score, but not enough wisdom. There was a kid in my class, and their parents had just moved. Their parents had just moved there. They were from a foreign country. I'm blanking on which. I think it was Korea. The kid obviously had a lot of difficulty, like, you know, didn't speak the language at all. You know, there were people trying to help him with that, but it didn't always work out. And I felt really bad for him. And so, of course, what one does when one hears that your classmate is in trouble because their reading scores are really bad is you use a hex editor to edit the binary save files for the Turbo Pascal program, and you fudge their reading scores. And it turns out that it's really suspicious when the person who literally speaks not a single word of Dutch suddenly gets like perfect A's on their reading scores. That is improbable. And so it was, unfortunately, the teacher quickly figured out what happened because, I don't know, there's only a handful of ways that could have happened. And so that was the first time I got in trouble. The good news is that like I got really lucky because apparently my one main piece of advice is get in trouble before you're old enough to be held accountable for your actions, I guess is sort of the conclusion. But
it's really,
sorry?
No, it's really interesting that you started perceiving the system as something to break really early on, because I was also getting into computers, but I didn't perceive this as sort of something I can really break into. I was looking at what can I build into. I wonder what can I build real fast with it, or so I was looking at this as a kind of system that exists and it's consistent, and you're looking at the system as, okay, can I hack into this? So could it be the key to your kind of getting into crypto, just this sort of mindset?
Yeah, I think, I don't know if it's like cause or effect, but I mean, they're clearly interrelated. And so Fortunately, instead of just disciplining me and keeping me far away from computers forever, what this teacher decided to do is, hey, we have all of these computers that we scrap together from parts, and they barely work half the time because there's a bunch of kids on it, and they mess all the machines all the time. How about we pull you out of class for like a week a day, and you just like wander around and go fix computers? And that sounded way more fun than the classes that they were actually trying to teach me. So I did that for a while. And then, so the other thing, which I think is definitely a security thing, my dad was a magnetic head engineer, and one day he told me like, hey, have you ever thought about how ATM cards work? I was like, I don't know, maybe like 8 or 9. I'm sitting there thinking like, no, actually I don't. And so he, tells me like, well, there's a mag stripe on the other end. Like, think about what sort of things can a mag stripe do? And long story short, he basically told me like, okay, well, look, you can get like an advance on your allowance if you figure out how to clone my ATM card. And so I did. So, that one was definitely like, that was a good start for, hey, rules are like, how does the system work? How can I subvert it? So I think those are two sort of like good Genesis stories that definitely got me started.
So now you're part of Latacora. So you're principal at Latacora, and your Latacora focuses on security for startups. Can you tell me a little bit more about the motivation behind joining Latacora, and actually Latacora's motivation to focus on security specifically for startups?
Yeah, so when we started Latacora, like technically I'm not a co-founder, but I started before we had our first client, so I feel like I got in pretty early. The other people who started Latacora came from a company called Montesano, which used to do application security. And I came from, my job before this one was at Rackspace Managed Security, and so we did managed security services. So like having like a security operations center and like having all sorts of agents installed on machines and figuring out what's going on with your network. And despite the fact that we were coming at this from like totally different angles, right? Because they're trying to find application security vulnerabilities, and I'm trying to shore up networks, right? Like they're both in security, but they're pretty far apart. But we had kind of the same idea, which is the things that we're doing are useful, but they're not useful to startups. Like there's no good way for startups to consume any of those services. There's a variety of reasons for that, but a lot of them involve like, as a startup, you don't necessarily have the resources to do anything useful with that input, if that makes sense. So like if you get an AppSec test and somebody tells you, like, oh, you've got these, we find this XSS vulnerability, what they're probably not going to tell you is what you really should be hearing, which is you have this systemic problem where, you're building websites this particular way, and if you just built them this other slightly different way, then you could just not have this problem in the future anymore. So, if you're a Fortune 50 company, then getting third-party application security pen tests is a fantastic value for money, right? Like get more people to look at your apps. Great, keep doing that. But if you're a startup, like first of all, AppSec is not the only thing that you need. There's all these other things that you might be getting compromised through, and in fact, far more likely that you're going to get compromised that way. And then simultaneously, like even if you just focus on just AppSec or just NetPen. Just because somebody tells you, hey, you missed a spot, like that's helpful if you have a real security team that knows what missed a spot means, but it's not helpful if if this is like the only audits that you're getting. So bottom line, simultaneously we figured like, hey, look, the things that we're doing, there's nothing wrong with them intrinsically, but they don't really work well for startups. And then secondly, the startups are the clients that we want to work with. Like they're interesting in a lot of ways. Like they're doing new stuff. And so, okay, well, what do we do in order to create a program instead that is specifically tailored to startups? So how can we help startups build security teams? And what we came up with is that we work with startups as an alternative to the first security hire for about 12 to 18 months. We find that's sort of like our sweet spot. Technically, it's like half a year minimum, but like 12 to 18 months is where we do best. And during that time, we build all the things that we think you should need as a startup security practice. So that means we start out with like a comprehensive audit. We look at all of your systems from a whole bunch of different angles. So we do we do NetPen, we do application security, we look at your cloud deployments. We look at what we call deployment security, which is basically like how does code leave your developer laptop between that and it ending up in prod, like what happens in that space. And we also look at like what we call corporate security, which is how do you manage your laptops? What does your VPN look like? How do people sign into stuff, et cetera? And so a lot of those things are things that, would be, that are hard to get in a sort of traditional transactional security model, because you're supposed to have in-house, IT or security people who do that, except when you're a startup and then you don't have those people. So the idea is that we deliver those services for startups by just being around and being their security team for about a year. Interesting.
I think it's really valuable from another standpoint. Usually when you join a company or look at the company that became, as I say, Fortune 500, 50, or even an enterprise one, they have this IT department and it tries to become secure. But it looks like you, from the very beginning, from the very inception, you make the security holistic approach, IT and audits and the way people are deploying stuff into the very beginning. It seems like a really valuable thing to do, to be honest. And the fact that you're going from this realization from Matasano's pen test way to auditing and figuring this stuff out is also really important, really interesting. But I'm curious, what is your day-to-day with any kind of example? You don't need to name the startup, but just generally, okay, you start your day and you think, okay, I'm gonna do security audit on this code, or I'm gonna do network scan, or like, what is your, how does that work with Latacora joining the company? What was the usually begins with, and what do you do after, like the first steps?
Yeah, so it's definitely super varied. We generally divvy the engagement up into two main parts. So we start with, I don't know, like a month and change worth of those in-depth audits, which is basically sort of like us trying to get to a state of the union. We try and figure out like, okay, look, here's where your app is, here are some of the problems that you have, and come up with like a series of tactical recommendations and strategic recommendations. So things that you should go fix right now, and things that like, hey, look, over the next 6 months, we'd like to see you move towards more of this because you'll have security advantage Y. So that's the first chunk of the engagement. And then for the rest, there's a bunch of stuff that we'll do on a sort of day-to-day basis. So for example, we'll do code review and advisory services at an earlier, more of a design stage. So sometimes we'll have a conversation with someone and they'll tell us like, okay, look, I want to embed this widget in this partner site. And then we'll talk to them and figure out like, okay, well, look, can you actually do that securely at all? What are the downsides to that? Like, okay, look, what happens when partner sites when the partner site gets compromised? So we do that at first at the design layer, and then later when people show up with actual pull requests, we go audit the pull requests. Obviously, the pull requests are going to have we're looking for different vulnerabilities at that point. Like within the design doc, you're looking for sort of like semantic flaws, and within the pull request, you're looking for very concrete flaws. Like within the pull request, it might be like you have a cross-site scripting vulnerability, like right there, right? Or you have like an auth failure right there, or something like that. But like generally speaking, we'll do pretty much anything on an advisory basis. And what I mean by that is, we will help you, like, we don't want to be the security team that says no all the time, right? Like, I don't want people just like show up and I tell them, like, no, you can't have this because X, Y, Z. So what we try to do instead is we make sure that all of the people who are involved in a particular project, and that could be people in legal, that could be people in, product management, that could be people like individual engineers, but we want to make sure that they understand exactly what they're doing. From a security perspective. So our job is basically to get you to understand risk, and we will certainly advise you whether or not we think that's acceptable, and in most cases we'll be able to give you an alternative. But at the end of the day, like what we're not going to do is litigate you into doing the right job, into doing the right thing, right? Like we will tell you what we think the right answer is. We'll tell you how to get there. But at the end of the day, like you can take a horse to the water, but you can't make a drink, right? And there are certainly cases where, look, the best security answer might not be the best business answer because, I don't know, like you want a super low friction UX, and as a consequence, you can't have super strong auth because your users are put off by the idea of TOTP 2FA, right? Like it's possible. And the only thing that we can do is like make sure that you really understand what you're getting yourself into. And, maybe if the answer, if you ask us 100 times and we tell you 100 times, like, we think this is unsafe, and 100 times you decide, yeah, well, that's cool, but I'm going to do it anyway, then maybe you don't really need a security team, and that's okay. Right? Like, I mean, I'm not judging, right? Like, I'm not saying that's necessarily a bad thing, but, there are certainly companies out there that like the idea of a security team and don't love the idea of actually having a security team. Maybe this isn't a good fit, and we're going to go find someone else to help.
Gotcha. Okay, I want to go back to Latacora a little bit later when I'll be asking some war stories, like really interesting things that happened to you. But before that, I want to really get your answers on Crypto 101. We know that it started as a presentation at PyCon, but what were the real motivation between Crypto 101? I know that you're still working on it, and what do you want to add there? So let's just talk about this for a little bit.
Sure. So motivations for Crypto 101. First of all, before Crypto 101, people basically, like, the standing advice for anything cryptographic was don't do it, or at least, the famous internet meme, don't roll your own crypto. And that doesn't actually work. Like, you can't just, I mean, you can say that, but it's not particularly helpful. Why is that not helpful? So first of all, people misunderstand what you mean when you say don't roll your own crypto, because you'll get things like AES-ECB, which is totally insecure. If you don't know why, you should go read Crypto 101, or go watch the talk. I talked about ECB in the talk too. And you'll get AES-ECB, and people go like, yeah, but you told me not to roll my own crypto, and I didn't roll my own crypto. I used AES, the advanced encryption standard. How could this not be good? It's advanced. And so, there's a clear mismatch there between what people thought that you meant and what you actually wanted them to do. So first of all, there's people, that wasn't really helpful advice. And then secondarily, there wasn't a lot of good resources for teaching people like how to implement specific cryptographic strategies. That can be anything from as simple as go encrypt this email address to something as complicated as I want to have a shared secret between my laptop and my phone. Like, I have an app on my laptop and I want to pair it to my phone, and how do I do that securely without having to type in a 25-character password or something like that. So there wasn't a lot of good advice for how you do that. Also, there were a lot of people who were sort of interested in this kind of thing. But I guess I disagree with the premise that teaching people anything about cryptography is a bad idea, because if you teach them something, then they will know enough to be dangerous. At the same time, if you look at the people who actually know what they're doing, and you look at the crypto that they implement, you'll see it's all hyper conservative, right? Or a lot of it, a lot of competent developers who have a lot of knowledge about how you securely and insecure, how you can do cryptographic primitives or cryptographic schemes securely and insecurely. When you look at the things that they come up with, it's boring crypto, right? People love boring crypto. Google's fork of OpenSSL, where they basically try to make it a secure subset of OpenSSL where they don't care as much about backwards compatibility, is called boring SSL. They consider this a compliment, right? They want their crypto to be boring. And so clearly, there's this dissonance where you can't say simultaneously oh, we can't teach people. Also, the people who already learned don't make these mistakes. Clearly, there's a difference there. So the approach that Crypto 101 takes instead is an approach that CryptoPals takes as well. So CryptoPals is from Matasano. And that is, okay, look, we're going to show you the simplest thing that could possibly work. And then we're going to teach you how to break it. And then we're going to move on. And then we're going to teach you how to break that. And then we're going to move on. We're going to teach you how to break that. And at the end of this entire endeavor, after, you end up with TLS. And at the end of it, I don't have to say TLS is good, you should use it. If you want to know why, well, now you know why, because all of the bits and pieces in TLS, the bulk encryption, the authentication sometimes you have authenticated encryption in modern TLS, but you know why you need, why you can't just use AES-ECB. You know why you need to authenticate your ciphertexts. You know why Diffie-Hellman exchange is important. You know why signing matters, et cetera, because I made you break all of those things. So if you take literally any single piece away, then TLS doesn't work anymore. And so hopefully that, by doing that, I'm hoping that, people who make it all the way through Crypto 101, they just have this sort of newfound respect for TLS, and then therefore stop messing with it. I don't know if that's like, so far that has mostly worked out. Like, I don't know of anyone who has went and gone off and done like awful things as a consequence of Crypto 101. I've certainly know people who have gone off and done awful things, but I feel like, most of their knowledge seems to have come from Wikipedia pages. And those people were going to be dangerous no matter what I do. So, did I answer?
Yeah, interesting. You mentioned that there's a notion somewhere that you should not really teach people crypto because if you teach them wrong, they'll become dangerous enough. Is that a widespread notion in the security community? Is that changing with? Is that the Crypto 101? Is that sort of your way to try to change this notion? How does that? What do you see out there?
So I don't, to be clear, I don't think that every single developer should read Crypto 101. It is targeted at every developer, but that's because that's in terms of level, not in terms of like, I think that every developer should have read the book. It is strictly for people who are interested in it. What I do think that we need, so we wrote a document called Latacora's Cryptographic Right Answers, which released, I want to say a couple of weeks ago. And that has very little justification, right? Like it just says, if you want to encrypt a string, you should go use secretbox out of NACL, right? It doesn't tell you why secretbox is good. I don't need to explain like adaptive, I don't need to explain chosen ciphertext attacks, again, in order for you to understand that like you should just go use secretbox. Secretbox is good, stop worrying about it. I think there's certainly a lot of value in being able to just communicate what the right answer is. Crypto 101 goes way further than that and like actually does go through the breaking. I don't think that's necessary. As for the general security community, I've heard it less and less. This idea of like don't implement your own crypto, like people still say it, but I get the impression that it's dying down a little bit. I don't know. I don't want to go so far as to say like crypto, like it's gone and Crypto 101 fixed it. Like no, I don't think that's true at all. But I certainly hope that I contributed in whatever small way it is. Like if there are less crypto vulnerabilities tomorrow as a consequence of Crypto 101, then I'm happy. That was the only thing I was going for.
Cool. Look, I have tons of questions to you about general advice for startups, and I want to jump into them. So it's interesting that startups are mostly concerned about survival, especially in the early stages, and very often security is not on top of their priority list, as we know. And actually, you sort of answered part of this question already. Is there any very simple list of steps companies can take to get reasonably secure? So the Latacora Right Answers is probably one of these ways to get secure. Do you know any other kind of checklists or things that you recommend companies to do or not to do to become reasonably secure?
Yeah, so I definitely like the cryptographic right answers format for that, like the whatever right answers. I'm pretty sure that at some point I'm going to write like an AWS IAM right answers and like an AWS EC2 right answers, whatever. A bunch of those because I don't know, people seem to like them and they seem to be helpful. So we'll probably do more of that. I think I understand what you're saying, but I want to almost like object to your premise a little bit when you say, like startups are concerned with survival and security is not a huge priority. That's certainly true in a lot of cases. It's absolutely true that security costs money and it's money that a lot of startups don't have. But at the same time, we've also spoken to a lot of startups for whom like security is a major selling point, like where, they're closing sales because they have a way better security story than their competitor. And also like, obviously getting popped early on and, probably making the front page of the Orange website, having a bunch of people tell you why you're stupid for not having patched your Jenkins or whatever it is they got you popped. That's also not great publicity. So I don't know if it's generally true that there's certainly a lot of startups that we've spoken to. I mean, obviously there's massive selection bias there, right? Because it's the startups that we, a security consultancy, have spoken to. So it's only the subset of startups that are already vaguely interested in security. But that said, like there's a lot of startups that are trying to do a good job and they just don't have access to resources to do them. So there's a handful of things that I would recommend people do overall. So let's see. First of all, stop using the AWS console. Just don't do it. Have a separate account if you must, if you want to mess around with stuff, but don't do it in your prod account. install AWS Vault. It's a project by, I think, 99 Designs. I'm sure we can get the link to people somehow after this call. What AWS Vault does is instead of putting your credentials in plain text on your disk, it puts your credentials in your operating system keychain, which means that it's way harder to accidentally lose them. And this absolutely happens. Like, if you, we've seen people like, accidentally publish like their dot files, which have like their bash RC or their Z shell RC or whatever in it. And of course there's an AWS access key in there. 5 minutes later, people are mining Bitcoin. So yeah, that's AWS Vault, fantastic. Manage as much of your infrastructure as code as possible, as early as possible. So I don't really care how you do that. Kubernetes is great. And like Terraform is better than some of the other tools. I've certainly had, I've seen as many Terraform setups as I've seen as the number of Terraform setups that I've also seen blow up. But that said, it's not foolproof. Let's put it that way. But it's still like it's 1,000 times better than manually managing a bunch of AWS servers. In-state mandatory code review. Make sure that at least a handful of your engineers. You don't need everyone to be an AppSec expert. But if you have like a handful of people that like know what server-side request forgery is or something like that, then you only need a handful of those plus mandatory code review to effectively inoculate your entire application, right? Because like there's always going to be someone who's looking at this code once in a while, and there's a pretty good chance that they're going to be able to spot that kind of vulnerability. Don't have infrastructure unless you're serious about managing it. I poked fun at Jenkins earlier, but like I seriously think that like 100% of the customers that have a Jenkins, like there is gonna, like I'm worried about that, right? Like I'm not saying that there's necessarily an RCE that's gonna fall out of that, but Jenkins has serious security vulnerabilities every week. So I'm not saying Jenkins is awful. I'm saying if you have infrastructure, you have to you own that now, and you don't get to half-ass it. Get WireGuard. WireGuard is WireGuard is a VPN. It started out for Linux only. My understanding is that there's a macOS client now that works well. I haven't tried it because I don't use Macs anymore. But WireGuard is super easy to set up. It is crazy fast. Like you don't have an excuse to have anything listening on the public internet anymore, in my opinion, other than WireGuard. And for like if you can get rid of SSH keys on disk, kind of the same problem with AWS. Credentials being on disk unencrypted, get like Teleport or another SSHCA in order to just don't have SSH keys on disk. Yeah.
Interesting. That's a lot of advice, actually. Thanks. Packed in a couple of minutes. Interesting patterns that I've noticed in your advice is that generally you don't recommend to do anything manually. So, for example, don't use AWS console and prefer infrastructure or any operations as a code. Is that because it's easy to review them, or is it because that humans are error prone, or why don't you like AWS console?
So there's a couple of reasons why I don't like AWS console. So first of all, for example, we have a work sample test that we use for potential employees. Like we give them the work sample test, and the work sample test is like you get access to an AWS environment, and it has an app running in it. And there are some misconfigurations in the AWS environment that have security implications, and there are some misconfiguration or like bugs in the app that have vulnerabilities that have security consequences. And for some of the trickier ones, one of the design criteria that not just I, but also attackers use to try and see whether or not a particular intentional misconfiguration, like basically a backdoor, or some other compromise of your environment, whether or not that's interesting. One of the things I'm looking for is this entirely invisible from the console, right? And there are plenty of things like there are interesting CloudTrail misconfigurations that are literally invisible from the console, or like in some cases they're literally invisible, as in no amount of clicking will get you to that information, and in some cases they are de facto invisible because like you'd need to go to 17 different pages that are not obviously linked together before you'd be able to put that together. So there's no way you're actually doing that. One of the reasons I actively dislike, there was actually a published vulnerability today from a vulnerability that was a consequence of one of the default managed policies that the AWS created for you had like some bonkers wide permission that basically allowed people to do effectively account takeover. Generally, I don't like the default managed permissions that AWS gives you anyway, but console just adds to that, because every time that it's really easy to go into console and click like, oh, Redshift, right? And then the console goes off and creates like 15 resources. It doesn't tell you about most of them. And most of them are just like garbage that you don't want in your account. So if you are going to do, which is hence the advice, like if you are going to mess with a specific service, like fine, you can use the console because it is faster to get started. I do recognize that. But go do that in a separate account. Like don't mess up prod. Does that make sense?
Yeah, that makes a lot of sense. Also, you mentioned, so basically, visibility is a big problem on AWS console, and default settings that are not usually easily audited, or some misconfigured default settings that you don't have control of are a problem with AWS console, or any actually UI kind of templating out of the box thing. You mentioned Jenkins, and you said that Jenkins, you don't necessarily say that Jenkins is terrible, but at the same time, everyone who has Jenkins you're worried about. Kind of curious, Jenkins obviously has a lot of problems, but are there easy ways you would recommend to secure Jenkins out of the box? So is there some sort of pattern or Terraform example that you guys can publish on Jenkins, on Latacora, or anything like that we out there can use? Anything that comes to mind?
That is a really good question, and I'm not sure. But sort of some general advice, I guess, with things that I don't that tend to get you into trouble with Jenkins. So one of them is like people install Jenkins, and it's like one of the first pieces of infrastructure that they have, because you need a build server, something needs to deploy, right? Yep. And therefore, it's like the odd duck out, and it's like the one piece of infrastructure that's not managed properly, the way that every other piece of infrastructure is. And so Jenkins tends to be worse at getting updates. So just one of them is just like update Jenkins, right? Like it's not complicated, just keep patching. And the second part is, so one thing that I do have problems with is there's a lot of people that use Jenkins, like not just to produce builds, but like a build artifact where like literally what you do is Docker build, right? Docker build -k myapp dot. But what they're also doing with Jenkins is like deploying an entire piece of infrastructure. And so de facto, like they're running Jenkins on like this random AWS instance, and the role for the AWS instance is basically like, star. It's just got admin access to everything, right? And then the problem is like, okay, fine. As soon as I pop Jenkins, like now I literally just have your entire AWS account. So if you are going to do that, that's fine. I certainly like the idea of having as much infrastructure automated as possible. But consider doing things like use AWS roles in order to like temporarily assume a role in order to be able to modify some infrastructure, right? You have to do some work in order to get there, but there's a bunch of benefits that you get out of it. Like you get like significantly better audit logs because every time you assume a role, there's like a Cloudtrail event for that. You get much better audit logs, and you also like you can start narrowing down what the things are that that Jenkins has access to.
Makes sense. So, okay, basically take care of your Jenkins. Make sure that Jenkins is not root on your infrastructure in a sense of being able to do anything with your AWS account. And if you use Jenkins, try to limit its capabilities by separating the workloads of the Jenkins itself, like to building and publishing only, and actually leave deployment parts to some other piece of infrastructure. That's sort of what I heard from your advice. Interesting. That's really helpful. Going to another piece of infrastructure, languages and frameworks, and generally it falls into this pattern that as one of the startup participants of the startup community, I personally would love to see more from crypto and security community is more prescriptive advice, right, in general, and that falls into the same applies to not only to Jenkins and things like that. But to languages and frameworks. So are there any languages and frameworks you have seen delivering the most problems? And are there any languages that are, in your opinion, are better or delivering a good level of security, and some languages that are, in your experience, are worse? And we don't necessarily say that this language is bad, don't use it, but are there any examples of some languages that really were problematic for your security audits, and something that you've seen languages promoting that they shouldn't be doing?
Yeah, so it's really interesting to hear you say that you're actually actively soliciting that kind of advice, because I don't know, like I guess maybe I try to be nice too much, but like one of the things I was maybe not too worried about, like the cryptographic right answers document, but like it's very similar, right? Like we're not just telling you, in some cases we're telling you literally do this, and in a lot of cases we're also telling you like specifically don't do this. And I feel bad about doing that for kind of to your point, like it almost feels like it's a question that's angling for me to say like PHP is bad, stop doing PHP. PHP is bad, stop doing PHP. Like there are frameworks that you can write reasonable PHP software in now. But you're not the first person to tell me like, no, you should get significantly more prescriptive and just say like, these are the things that Latacora has vetted that that you should go use, and I should just get over my hesitation, and we should just start doing that. So one case where I've seen that very specifically, where tools have just obviously made everything better, is for cross-site scripting attacks. So for those of you who don't know, cross-site scripting is a style of injection attack where because you are not properly sanitizing input or not properly escaping input, you're putting some attacker controlled input in typically the DOM, so somewhere in, for example, the HTML that you're generating on your page view. And as a consequence of that, the attacker gets JavaScript execution. Now, if you're like a modern single page app that just interacts with an API, like all your app does is be some JavaScript and interact with an API. So if the attacker gets to run JavaScript too, then that's account takeover, right? So like it's a pretty severe vulnerability. And so an example of where stuff has just gotten magically better because the tools sort of like accidentally fixed this problem. Like I don't think it was a conscious design choice, but like somehow accidentally fixed this problem. Is so for example, like a lot of it we've seen a lot of like XSS come out of like poorly conceived jQuery code, because jQuery makes it really freaking easy to call .html with some accidentally under sanitized input, and before you know it, you got an XSS vulnerability. React has basically made XSS go away, right? Like you have to call dangerously set inner HTML. It's literally called dangerously set inner HTML in order to get an XSS vulnerability out of React. It's fantastic. And the reason that React is able to do that is just because fundamentally injection vulnerabilities are about context, right? Like you need to know, is this string that I have, is this like attacker controlled text? Or is this already some JavaScript, or is it JSON, or is it HTML, or CSS, or whatever it is? I need to know what it is in order to correctly be able to put it in context. React, because of the way that it builds the DOM, like it always knows whether or not this is an attribute, this is some JavaScript, this is whatever. So we just seen significantly fewer vulnerabilities there. On the server side, so classic PHP, and I want to make very clear, I'm saying classic PHP. I'm not saying all PHP apps are definitionally screwed. I'm saying if this was, the way that you would write a PHP application in like 2005, where you have a file ending in index.php, and you're embedding some stuff into a HTML page, then that is sort of like a cornucopia of XSS vulnerabilities, right? Because like there's no way that escaping went right there. We got a little bit better with that with like Django templating, because Django templating at least escapes stuff for HTML by default. The problem with that is that it's significantly more complicated than that, because you're not always doing HTML. So for example, let's say a common example that I've seen of this is you have some JavaScript. You have like a script tag somewhere in your page that you're loading, and you want to like embed a JSON document, or like JSON object. And how do you do that in Django, right? You can't just like put it in there, because it'll get escaped as HTML, and like your script tag explodes, so it doesn't actually work. So what you do is you pipe to safe, which again, like to use the React example, is the dumbest name for a filter that I've ever heard. Like it shouldn't be called safe. It should be called ridiculously dangerous, don't use. Don't call it. Like, I know where the name comes from, but like that's not what we should have called that function. I kid. I get that this is backwards compatibility. They can't fix it anymore. I'm sure that I'm not the first person to complain about that function name. I don't want to give them too much of a hard time. But as an example of how you can go even better and make this even better is Go's HTML template. So if you look at the escaping rule, and yes, for everyone listening, yes, LVH is saying nice things about Go. Savor it. It's not going to happen very often, but Go's HTML template is fantastic, right? Like, so if you look at the escaping rules specifically for it, it knows about all sorts of contexts like JavaScript. Like it knows if you're looking at an attribute, or if you're looking at like a DOM string, if it's an attribute and it's like on hover, it knows that that's actually JavaScript. So the escaping rules for that are subtly different. It knows about like title tag being slightly different than everything else. Like it is really awesome, and it's pretty hard to make. Like I'm not saying you can't get XSS out of Go's HTML template, but like you have to go out of your way. Like you're doing something weird if you manage to get XSS out of that. So I think that's a nice example of how things are getting better. I want to say sometimes by accident, sometimes intentionally. So like certainly Go's HTML templating, like that is an intentional security feature that they added, right? Like, and it worked out. For React, I want to say they accidentally fixed XSS on the front end. I don't think that was a design goal. But whatever, it worked. I'm taking it.
Yeah. It's interesting that your advice is as practical as it could be, because you're not endorsing the language. You're endorsing certain practices in certain frameworks that could be part of the language, could be outside of the language. So my feedback to you, as someone who really seeks this advice, would be don't hesitate to give this pragmatic advice and say, hey, Go HTML is great. It doesn't mean you endorse Go in general. I'm just saying, hey, this is a great way to do this, and we like that it's working. Do you have, actually talking about security advice, how would I differentiate, or listeners and anyone else, between good and bad security advice without being a security expert myself? For example, if you Google security cipher modes and like Nginx right now, there will be 15 different articles about with all different, unknown abbreviations to many of us. And some of them will be upvoted, some of them will be saying like, hey, this is bad, don't do this anymore. So is there anything we can do to differentiate, to understand, hey, probably this is something about this security advice that is not good, and this is why? Does anything come to your mind?
So I don't know of anything, and so that's a huge problem, right? And so one of the things that I think makes security and cryptography in this specific, but also security in general, really hard is that a lot of the time getting it wrong looks exactly the same way as getting it right. Like it's not, if you're not a security person and you're looking at, like a jQuery XSS vulnerability, it's not staring at you, right? Like with the exception of, React, where you call dangerously set under HTML. Like, I don't know, that sounds dangerous. So I don't know of any sort of like general rules, except for, the usual rules for like, how do you be an adult in modern society? Well, it involves a lot of critical thinking. And if somebody is also selling you a product, then that maybe you should give them a little bit of extra scrutiny before you believe what they're buying or what they're selling. But I don't have any great ideas. And I also appreciate that. And again, maybe this is something that only I am worried about, and I should just get over it and get on with it. I'm cognizant of the fact that when we say, that we do things like cryptographic right answers with Latacora, and we're going to do more of those right answers documents. But effectively, what we're saying is, like, you should use secret box because I say so, right? Like, there's no justification. Like, I'm not going to argue with you about whether or not secret box is good. Well, I mean, it turns out if you say bad things about secret box on Hacker News, then I will probably argue with you about why secret box is good. But like in that document, we're not going to argue with you. I'm not going to litigate you into believing that secret box is good. If you want that, then fine. The Crypto 101 still exists. Go read the book. But it's basically like, I think it's going to boil down to a handful of people that, for better or for worse, have good reputations, and hopefully reputations sort of kind of map to competence, but they certainly don't always. And have just like a handful of people that you've decided to trust and hope that those people put out advice. Like I'm really sorry, I got nothing. If you figure it out, please let me know, because that would be very useful.
Well, actually, I think you answered your question, but in two parts. The first part, you said, look, we have to give good answers in the form of Latacora answers, but at the same time, you have to back up your answers without being just authoritative, without justification or backup, by pointing to your Crypto 101 book that gives anyone reasonable explanations about why did you actually pick this answer. I think the combination of those two will allow people to, first of all, see the answer if they're quickly looking for an answer, and then with two given different advices, they can pick one that gives more backup in form of more advanced serious answer that they can look in their own, or maybe ask someone on their team to look into. And then if there are two advices on the internet, one is not backed up by anything, and another one is backed up by the whole book that you wrote and reviewed it and published it and talked about it, that makes more sense, because then it means that it's not just an authority, but it's an interesting kind of combination of this really brief, short advice backed up with a more detailed book, or more detailed, elaborative part of it. So I think that will be actually really good. Look, I have a bunch of questions, so let's move on. I wanted to ask you the same question about, is there anything about clouds that you think differentiates them in a security way? So is there, for example, Amazon is more secure, in your opinion, than Azure or Google, and why?
So I think the big clouds are like, I would generally be wary of people being on like tiny VPS providers for anything that isn't like a toy project. So AWS, GCP, and Azure are sort of like, the major ones. And for like AWS has a ton of power in IAM in their identity and access management suite. Unfortunately, like IAM has its warts, but it does give you a ton of power. Like it is extremely expressive. There's a whole bunch of, the good news is there's a whole bunch of tools. The bad news is there's a whole bunch of tools. Like in particular, like if you just wonder something as simple as, hey, I have two instances, can they talk to each other, right? Like, okay, well, you have host firewalls, you've got security groups on the instances, you've got network access control lists, you've got VPC peering, you've got AWS Direct Connect, so they might be able to talk to each other via like, some other bizarre link. Like there's a gazillion different ways that an instance might be able to talk to each other or not. I haven't even mentioned VPCs. So like VPCs themselves, like they can be VPC separated. It gets complicated pretty quick, but at the end, so obviously like in the cloud, you have the whole thing about the shared responsibility model, right? And I think from like that perspective, I think that AWS and GCP at least are going to be on a pretty similar level. So in terms of like, are the underlying hosts going to get patched the next time that there's a Zen vulnerability? Like, yes, AWS and GCP will get their shit together and patch all their Zen vulnerabilities. But the like more generally, I think the question is, do they give you the tools to adequately secure what you run on top of the cloud? And I think that AWS is probably the forefront there. GCP is like second. I haven't worked with Azure recently enough in order to tell you whether or not it's where it used to be. Where it used to be was like it was fine, but it wasn't great. Like it wasn't AWS grade. AWS has a bunch of like extra tools like AWS Inspector, and there's like AWS Guard Duty, and I don't know, they're a mixed bag. Like you should go turn on Guard Duty, sure, but like the problem with, as I'm sure many of you know, the problem with a lot of these automated tools is they produce a ton of noise, right? Yeah, it's a mixed bag. I think AWS is probably in the lead. GCP is really close. I would be very wary of anyone trying to run anything on a small VPS.
All right. I want to go back to your Latacora experience, and just mostly really curious, is there anything you can tell us, kind of some war stories from working on startups, especially the most common tech security mistakes and security holes you have encountered so far? They're so common that you just want them go away, you want to tell everyone about them, not necessarily mentioning any company, of course, but is anything standing out?
So definitely in terms of AppSec, I mean, we found XSS at most customers, except the ones that are sort of like definitionally immune because they have, I don't know, they have like a JSON API with some React and like not a lot of opportunity for them to mess it up.
Yeah.
When that, like, if I think it's pretty fair to say, like, if you load jQuery, then I assume that you have an XSS vulnerability.
Okay.
Another attack that we've seen show up several times is like SSRF. So it's server-side request forgery. Basically, it's like when you have like a webhook, something that that calls back out to the internet in order to notify someone that something got done or whatever, you're able to point that request at something else, and now you're making requests from the server itself, which is potentially on a privileged network. If there's a bunch of services that you have that strictly rely on network segregation for safety, which is not good, like in order to exploit an SSRF vulnerability properly, like there has to be something else messed up somewhere. But still, like we found SSRF vulnerabilities in a bunch of places, especially in the context of DNS rebinding. So the idea is that you have SSRF vulnerabilities where something will resolve a URL and see what IP it points to, but the IP is on an attacker-controlled domain. And when you resolve it the first time, it gives you a safe IP, and you think that it's okay to connect to. And when you resolve it the second time, it points at 10.0001 or whatever, and then you're hitting an internal service. Something that I think not a lot of people have been thinking about, but that we've certainly found stuff, is G Suite authorized apps. So people will, like sign in with Google, right? And a lot of them just ask for your email address and like potentially your name or something like that. That's not a big deal. But there's a lot of those applications that like ask for access to Drive and like ask for access to Gmail. And I don't know about you, but like I get queasy when, some random, like calendar scheduling application wants perpetual access to all of my email forever. Like, I don't know, that sounds like a bad idea. And we've certainly found like a lot of applications that that can't really justify or can poorly justify the things that they're asking for. So that's a pretty common problem. SMS two-factor auth, like still a common problem. I was kind of hoping that like NIST would fix this because NIST fixed passwords, right? So NIST changed their recommendations for passwords, and now when people with dumb security questionnaires tell me like, oh, your password policy is insecure because you don't require symbols, then I can respond by, well, we're compliant with NIST, so go away. NIST are also like, SMS two-factor auth is bad and you shouldn't use it, and yet people are still using SMS 2FA a lot. And I understand why. Like for a ton of people, like SMS 2FA is like a fantastic UX, right? Because they have their phone on them all the time, and being able to type in like 4-digit code is easy. So like they love it from a user experience perspective, but dear God, I don't love it from an authorization perspective. And from an author perspective. So.
Gotcha.
Those are
yeah. Thanks for it. It's a lot of advice. I think I was actually writing all this down, and I'll try to email this to everyone as kind of advice from LVH. And I have actually the same question about processes. So you mentioned one process mistake on Jenkins level. So when people set up Jenkins, they set it up to be more admin than it should really be. Is there anything else about processes that you have encountered in those companies that made them less secure than they should be? Some mistakes, maybe deployment mistakes or logging mistakes, anything that comes to mind?
Yeah, so first of all, again, don't use the console. Like if there's one piece of advice that if there's one piece of advice you take away from this, it's install AWS Vault. If there's two pieces of advice you take away from this is install AWS Vault and stop using the console. And the reason for this is simple, right? Like if you're manually deploying a service all the time, like at one point you're going to be deploying a service at, 5 p.m. and this person's kid is crying and sick or whatever, and they're distracted for whatever reason, and they're going to mess it up, right? And it's not because they're bad human beings. It's not because they're bad at their job. It's because you asked them to do a task that should have been automated 6 months ago, and then you didn't do that, and then now it's a manual process, and manual processes come with potential for failure. Like this is a pretty well understood problem. Just don't use the console. Another thing that comes up a lot is I'm not sure if this is like a process or a tech problem, but CloudTrail by default had, first of all, people will put CloudTrail in unsafe S3 buckets within the same account. One of the things we tell most of our customers to do, once we get like the big problems out of the way, is consider having a separate account that dumps CloudTrail. And it just like only have CloudTrail right to that one S3 bucket in that account and like only read CloudTrail from there. By default, CloudTrail had hash file verification off. So CloudTrail has like a way where kind of like a Git repository where every new commit has in it the hash of the previous commit, right? So if you delete a commit in Git, like you can't lie about history or otherwise all the hashes change, right? And so kind of the same idea. That was turned off by default, which basically means like, okay, well, your audit logs are totally useless because the next time that I pop an admin cred, like the first thing I'm gonna do is I'm gonna look at your CloudTrail bucket and I'm gonna delete all of the evidence that I was ever here. And that's not very useful. So secure CloudTrail. CloudTrail I don't understand why the defaults for CloudTrail, I mean, I know the reasons behind them. I don't think that they're good reasons. They did change the defaults, but it was like 2 months ago. And it was insecure for years. So whatever, it's fixed now, but still bad.
Interesting. This is really valuable advice because people don't usually think about their audit trail as something that should be secure itself, because they think that the audit trail is something that looks at security of the system, but at the same time, you kind of go in one step further and saying your audit trail is a really important part of your security analysis as well, because if it can be tampered, it means that you're insecure. Really cool. Look, we're wrapping up. We just have 5 more minutes left, but I still have one question before we wrap up, and probably give it some questions, maybe get some questions from the audience. If someone can type their questions in chat, I'll try to read some of them at least. But there's one thing that always in the internet, on the Hacker News, everywhere, called Docker and Kubernetes. And the question that I see a lot, and there's a lot of debates around that, whether Docker or Kubernetes make security harder or easier. Do they make your job harder or easier? Why? Why?
I think there is the potential for it down the line to be a fantastic good thing for security. I don't think that we're necessarily there yet. I also don't think that it necessarily makes it worse right now, but in a lot of cases it does. So first thing that comes to mind when you say that is like Kubernetes' requirements for like every let's see, I get this right. Every pod has to be able to talk to every other pod, like the flat network requirements, basically like no netseg. People misinterpret that as that meaning like I've seen Kubernetes clusters that as a consequence of that, like, oh look, every host has like a public IP on the internet. Like, no, that is not what anyone said. Go back, you made a mistake. And also, but like the docs for this are terrible, right? Like I think if you go to, I mean, sorry, I don't mean to say terrible. I don't want to sound so negative, but like if you go look at like if you go ask the Kubernetes documentation, like how do I actually manage networking? There's like what 15 different providers that will all ostensibly do exactly the same thing. And you get confused by all of them, and then eventually you end up with either, I don't know, Calico, Flannel, or nothing. I kind of wish that was, I don't know, like I kind of to your point, like maybe as security people, there should be more, I don't know, more specific recommendation. One thing that is nice though is like, at least if you're, let's say that you're putting everything in Kubernetes, the upside that you have is you're already speaking a standard language. So if Kubernetes as a system improves, then in a lot of cases, you're going to be able to reap the security benefits from that automatically. So for example, one of the things that comes to mind is like, the Kubernetes secrets management thing, like by default, like that wasn't great. I mean, it solved the problem, but it solved the kind of weird problem that I don't think everyone has. I'm not going to start about secret storage because we have less than an hour left, so I can't start about secret storage. But the bottom line is, if you at least use, as long as the API isn't intrinsically insecure, if the thing that it's trying to do isn't intrinsically bogus, then at least you have the option of like, okay, well, look, at some point down the line, there's going to be a better secret storage system that I'm going to be able to plug into this, and I'm still going to be able to run like, Minikube or whatever it is to run Kubernetes locally, and I have like, insecure test secrets laying around, whatever, who cares? But then when I deploy it to prod, I'm going to have this, way better story. The other thing you get out of Kubernetes is like, hey, everything's written down. If you have like infrastructure as code is fantastic from an audit perspective. And same thing with Docker in general, like at least the fact that we've all agreed that you are going to produce an artifact and I can audit that artifact, that's an improvement, right? Like at least I know I have the potential to look at what's running. So I think it's generally in the right direction, but I don't think we're there yet.
Yeah. Oh, I've got a question from anonymous viewer asking, do you see the question? Has LVH ever encountered FIPS 102 in the field? Federal standards for validation of crypto modules. Perhaps they have seen startups that are trying to achieve FedRAMP compliance.
I have certainly heard the term FIPS 142 more than once in my life, not at Latacora specifically, and quite frankly, every time I feel like every day where somebody says FIPS 140-2, like that's not going to be a good day. Like I'm not going to be happy at the end of that day, not because it's necessarily a bad standard. It's just like compliance. So yeah, no, we have not dealt with FIPS 140-2 specifically. I mean, we've certainly mentioned it for stuff like, customer X uses this HSM that has that certification, or customer X uses KMS, which has this certification, something like that. But that's been nothing more than a compliance checkbox. Like, I certainly am not the person to do your, to get you FIPS 140-2 compliant. Like, no.
So we should go to Latacora to get compliant.
There are people who can help you with that, but that is not what I'm going to be doing. And we don't have any companies that are looking at FedRAMP. We've got HIPAA, and we've got mostly it's HIPAA now. Obviously GDPR for everyone. And there's, there's certain kinds of compliance that are kind of easy, relatively speaking, like PCI is, not the end of the world, like whatever, you can probably do PCI. But no FedRAMP.
Gotcha. Look, I think we're almost out of time. Actually, it's ramping up. We spent, I think, 1 hour. We're talking about startup security. I'll try to write everything that you said in the form of transcript and send it to the audience. I think we've got a bunch of really helpful really helpful advice on AWS Vault, on using why Kubernetes could be better and things like that. And if anyone has any questions, you can always email us. I will send the link. And I'll try to send some of those questions to LVH. Not sure if you'll have time to answer them, but thanks for everyone for your time. Thanks LVH for joining. I think it was really cool. I learned a lot personally myself today. Hopefully that was the same for the audience. And we'll catch up after.
Yeah, so just in closing, one of the neat things about Latacora is that because there's only like a handful of customers that that we can work with, so we've certainly had to say no to people that we would have liked to work with, that would have liked to work with us. You should not hesitate to ask us questions. Just because you're sending email to an address that eventually sometimes results in people signing a contract doesn't mean that we're going to try and sell you. You should just ask us questions. We are allowed on the internet. We're pretty happy to help, as hopefully you experienced this hour. So you should not hesitate to ask us questions. It's helpful for us. It's helpful for you. If there's anything that you'd like to see, we'd like to know. Yeah, thank you all for your time, and thank you for the opportunity to share some of the stuff that we've been doing this year.
Yeah, thanks, LVH. It was really helpful. We'll talk to you later. Bye-bye. Thanks, everyone. I'll share this video after as well. Bye-bye.